Hello everyone, my name is ANKITA KESHARI and I am from Balia, Uttar Pradesh. I am pursuing MSc in microbiology from Central University of Tamil Nadu, and today my topic is biofuel production from organic wastes. So these are the topics I'll be talking about. Examples of biofuel, what is biodiesel, what are the feedstocks for biodiesel, how biodiesel will produce, and what is biohydrogen, what are the feedstocks for biohydrogen, how biohydrogen will produce, environmental and economic aspects, challenges and limitations, future prospects, and conclusion. So these are the examples of biofuel: biogas, bioethanol, biodiesel, and biohydrogen. My fellow classmate will explain the introduction and the production process of biogas and bioethanol. And I will be talking about what is biodiesel and biohydrogen. So, what is biodiesel? Biodiesel is a renewable biodegradable fuel made from natural oils and fats. It is produced mainly through a chemical reaction called transesterification, where oils and fats react with an alcohol in the presence of catalyst. So, what are the feedstocks for biodiesels? We can divide it into two parts. First is waste feedstocks, and second is derived feedstocks. These are comes from leftover or discarded organic materials that would otherwise be thrown away, such as used cooking oils from homes and restaurants, animal fats from meat processed units, grease from oily foods and restaurants. And second one is derived feedstocks. These are grown or cultivated specifically for biodiesel production. They will not harm the crops, food crops, such as non-edible plants, for example neem, castor, and for algal oils, they also produce biodiesel such as chlorella. How biodiesel will produce, what are the steps of biodiesel production? So first we will collect the sample from the restaurant's microalgae, then we will heat gently the sample to evaporate the free water. We need to remove the phospholipids because the phospholipids is the main cause of saponification, and it will harm the engines in the future. Then the next step is acid esterification. In this we will treat the sample with H2SO4 and methanol. Then this chemical reaction change the processed waste oil into methyl esters and glycerol. Then the next step is transesterification, in which the precursor oil which we treated in the acid esterification step. In this step, base transesterification, we treat that with NaOH. Then the sample will convert it into biodiesel. Next is the step is the separation. We need to separate the biodiesel from glycerol by centrifuging. Then the next step is purification and finishing and the quality testing. Quality testing, we need to consider on low glycerol points, high flash points, low sulfur and water quantity, so that it will not disturb the engines in the future. If if the biodiesel will pass all the tests, then it will be useful for engines. So, what is biohydrogen? Biohydrogen is mainly produced with the help of microorganism. It is a renewable, eco-friendly fuels which can replace the fossil fuels. It can be made, or it will follow the two pathways, biological pathways. First is dark fermentation, and second is photo fermentation. So, what are the feedstocks for biohydrogen? First is carbohydrate based feedstocks. Second is lignocellulosic biomass. Third is industrial and agricultural waste. Fourth is wastewater and sludge. And fifth is lipids and glycerol. Carbohydrate based feedstocks such as sugars and starch. And lignocellulose biomass comes from plant waste. Industrial and agricultural waste are like rice husk and wheat waste, and wastewater and sludge comes from industry and all. Lipids and glycerol comes from restaurant, homes and all. So these are the steps of production for biohydrogen. So first, after getting the sample from the carbohydrate and sugars, we will grind the sample so that the surface area will increase. We will then hydrolyze the sample because it will give you good quality of biohydrogen. Then we have to maintain the pH and nutrient for the microbial activity. Then we will give all this sample in a dark fermenter. Then the microbial activity will start and hydrogen will produce. So in this dark fermentation, what will happen, the glycolysis between glucose and microbes will happen. Uh, bacteria In bacteria, glycolysis will occur. The glucose will converted into pyruvate, and then pyruvate goes to acetic acid cycle. Acetic acid cycle is more preferable because in butyric acid cycle the hydrogen yield is less. So bacteria more follows the acetic acid cycle for conversion of biohydrogen. Then we collect the effluent from dark fermenter. Then we feed this effluent. Effluent contains biohydrogen, small amount of microbes and small amount of microbes and water. So then we and a small amount of fatty acid also. Then we fed the effluent into photofermenter, where the photosynthetic bacteria will use this fatty acid, volatile fatty acid, and make the biohydrogen. Biohydrogen is, as I said, biohydrogen is more more formed in photo fermentation as compared to dark fermentation. Then we will collect the gas and purified it. So we need to see the environmental and economic aspects also. Using organic waste for biofuel often lowers net greenhouse gas emissions compared to landfilling or incineration, especially when methane is captured and fossil fuel use is displaced. Wet waste conversion such as anaerobic digestion, hydrothermal liquefaction avoids land and irrigation demands for energy crops. Biofuels like biomethane and biomethanol can significantly lower GHG emissions compared to fossil fuels, especially when integrated with carbon capture and utilization technologies. Selling our organic waste for biofuel feedstocks provides additional income, especially in rural areas also. Biofuel production supports employment in agriculture, engineering, logistics, and plant operations, reduces dependence on imported fossil fuels, stabilizing energy cost, and enhancing geopolitical resilience. So, what are the challenges and limitations we will face? We can face actually organic wastes varies in moisture, nutrient content, and biodegradability, affecting the process efficiency. So, agricultural residues and food waste are often seasonal, disrupting continuous biofuel production. Some organic materials are resistant to microbial breakdown, reducing very less biofuel yield. Lignocellulosic biomass requires energy-intensive pre-treatment to release fermentable sugars. Combining anaerobic digestion, pyrolysis, gasification demands advanced control system and skilled operators. Infrastructure for biorefiners, digester, and purification units is expensive. Small scale operations struggle to compete with fossil fuels or large scale biofuel plants. Biofuel prices fluctuate due to policy shifts, feedstock costs, and fuel competition. Carbon dioxide and methane and nitrous oxide compounds can be released during fermentation, and it will cause any other pollutions also. Improper handling and byproducts like digestion can lead to soil and water pollution. Scaling up biofuel may insensitize monoculture or divert land from food production. These are the challenges we can see. Uh, what are the future prospects? In this, I can say second and third generation biofuels, biorefiners, electrical and thermochemical innovations, carbon neutrality goals, waste management synergy. These will change the future. So, what is second and third generation biofuels? These are non-food biomass such as lignocellulosic waste, algae, and offer higher yield with lower environmental impact. What is biorefiners? Integrated facilities that convert organic waste into multiple products like biofuels, bioplastics, and biofertilizers, enhancing the economic viability. Electrochemical and thermochemical innovations. Techniques like pyrolysis, gasification, and electrochemical carbon fixation are improving efficiency and scalability. And carbon neutrality goals. Biofuel from waste can help countries meet net zero targets by replacing fossil fuels and reducing methane emissions from landfills. Waste management energy will clean the cities and will form the different types of fuels. So, conclusion. Biodiesel is a renewable, eco friendly fuel made from waste, oils, and fats. It will reduce the pollution also. So, using organic waste and it will also decrease the pollution and solve waste disposal problems. The main process is transesterification, where oils, fats react with alcohol and form biodiesel. Byproducts like glycerol and soap also have Commercial have also have commercial uses. Biodiesel is biodegradable, non-toxic, and cleaner burning than fossil diesels, and they will produce less carbon monoxide, sulfur dioxide, and particulates. And quality testing ensures biodiesel meets standards like IS 15607 is to 2022 in India, EN 14240 in Europe, ASTM D 607051 in the USA. Challenges include pre-treatment of waste oils, cost of production, and cold weather performance. Biodiesel supports the circular economy, security, and reduction of greenhouse gases. It is a promising alternative fuel for fossil fuels. Thank you.